let's try and test what we have so far. So we'll have to write our deploy script, and that's the next thing we're going to do now. So we come here, we create a file. We're going to name it deploy multi-dex bot.s.so. Because it's a script, you have to put .s there. That's the requirement in Foundry. So few things we need to set out for our script. We need to import scripts from the tools available in Foundry. This is our contract. It's multi-dex, and we have imported it from SRC folder. Then this console tool, I'm not sure if I'm going to need it, but let me just comment it out for now. Then the next thing is to start writing our deploy script. Basically, this is our deploy script. Our script has to inherit script tools from the Foundry library. Now, this is the address of Aave pool provider. Don't forget our contract in the constructor takes Aave, the pool provider address. So we are going to pass it in here at the point of deployment. Now, I said we are going to be testing this contract on base layer 2. We're going to fork base layer 2. So this is the address on the mainnet. You get that on the mainnet. So here is the address of here is the contract we have just written, and we make an instance of it and pass the address of the Aave pool provider. Then this will be deployed. All right. So to make it easier for ourselves, we're going to write the command for deployment on inside a make file. We're going to create a make file now. Let's create a make file where we'll put our command for deployment in make file. Right, so I'm going to paste the command I quite conversant with. So generally the make file takes our .env file. We are going to create that where we'll put our environment variable. This is our default Anvil key. This is the private key of the account we'll be using. This is not a real account. It's just a dummy account that Anvil or Foundry generates for us. So that's why I'm showing it here. If it's my private key, you're not going to see it here. So then we have Anvil. This command helps us to fork base mainnet and make it available as a local blockchain on Foundry for us to test. And this is the command for us to deploy. So it takes forge script, the location of our deploy script, and the deploy contract itself, the script for deployment inside our deploy script. Then it takes some network args parameters. Then we have the EVM version. Here we put our private key in, and this is the command. So it makes it a lot easier now. So to see, let's try it this way. Let me clear my terminal and run make Anvil, and let's see if it's working. Okay, I've not included my .env file. Now I've added my .env. I'm not going to show you guys my .env file, even though I don't have all my stuff are encrypted. Now, and that is what is expected as a developer. You're not supposed to keep your private key in plain sight. You encrypt it. Now, so what we have here, these are the parameters that should be in your .env file, and I'm going to Yeah, so I want you to look at this .env file example, and this is a public RPC node, so you can just copy this and use it as your RPC to connect to base mainnet. This is the default Anvil key. I'm going to show you where I got the default Anvil key from that I'm using in the make file. You can see it's here. So these are the things that should be in your .env file. The mnemonic is also from Anvil. So I'm going to run make Anvil now, and you're going to see everything. Now you can see it's fucking base mainnet. Now it's running now. We are on. Now you can see the first account here. This is the account address. This is the private key FF80. That's what I have in my as default Anvil key here, FF80. All right, so now we can now deploy our contracts and see. To deploy this make Anvil has to be running. Then we create another terminal. We open another terminal and we are going to run make deploy. Hopefully it works. I need to change to the right directory. Let me just run ls here. Right, changing to multi-dex. Multi-dex port. Alright, now we are back inside our project. Then I can run make deploy. Hopefully nothing to deploy. Is there something wrong here? The error was due to the fact that I needed to have a tab here, but I had a space. I've put the tab, then everything should be okay now. So let's come to this and start our local chain, make Anvil, then come to this second terminal. We are going to run make deploy. Hopefully it deploys now. Alright, good. Our contract was deployed successfully. This was the transaction hash. This was the contract address it was deployed to. This was the gas fees we paid. So if we come on the local chain, we should be able to see the transaction. Alright, this is the transaction hash. Then we have the contract address. So everything seems to be okay. The next step is for us to test. We are going to test this contract, and we are going to see if we are able to get flash loan and also repay it. So let's test this contract by interacting with it. So I'll come to this script and create a file called interaction with bots.s.show file. Alright, so let's include the basic things we require. So we need this script from the library of Foundry. We need these DevOps tools to fetch the latest version of our contract, the most recent deployment of our contract. Now this should be our contract. Let me quickly edit that. I'm going to copy here, then come here. This is our contracts, right? So now we need to install this Foundry DevOps. Okay, let me clear the terminal to make things a lot clearer to see. Forge install -- no commit. Hopefully it works. Alright, this is the right command. I think I missed that. This is a tool built by Cypher. You should check them out. Patrick is doing something great for the space. So it's going well now. All right, interesting. So let's move on to the script itself. Before moving on, we need to tell our project where to find this contract. So as before, we're going to come to this remapping.txt file. Yeah, I still have it open. So, and I'm going to define where it's located. So whenever it says Foundry DevOps, you should replace it with lib/Foundry DevOps/source/DevOps tools. Right? So another thing we have to do to also give the DevOps tools some permission. So we just come here, we come to the toml file. All right, then we are going to write this code. All right, so with this, the DevOps tool can work well and fetch the recently deployed contract for us. As before, we are going to start our script. So the script will be called start arbitrage bot, and here that's where we are going to define the parameters and call the contract. So this is how we interact with our contract. We are going to write this one function. It's in this script library in Foundry, and thanks to the DevOps tools we have, we are able to call this function called get most recent deployment of multi-dex bot contract, and this is the chain ID. Then it returns the contract address to us. Then with the contract address, we are going to call this function. I'm here to write this function. This is where let me just comment it out. This is where we are going to interact with our contract. So we have function start arbitrage. It's going to take address from arbitrage bot address. Visibility is not so important. Let's make it public. And this is what we are going to be writing. All right. Now let's call our contract. So this is how we're going to call our contract. We are going to call this function is flashloan enabled. So here, this function, what it does is it takes the most recent deployment version of our contract, the address. Then we wrap our contract around it. Then we can call this function called is flashloan enabled. Let's come here. You can see the function we are calling here. It takes address of the assets we are interested in. In this case, it's going to be a wrapped if that's worth. That's what we're going to borrow. Now, that function returns a boolean, and which is going to be either true or false. So it's going to help us to know that, okay, we are interacting well. So that's why I'm logging the response. Now, this is how we will now call the function start arbitrage on the contract itself. So if we go and check the contract, we'll see that start arbitrage takes two parameters, assets we want to borrow and the amount. So the assets we're going to borrow is wrapped if, and I'm going to define the amount now. This scan, you can easily get the address of worth. So this is the address of wrapped if on base mainnet. Now we also need to define the amount we are going to borrow. So this will be 256, and it's going to be public constant amounts. It's going to be, so let's borrow 10 ETH, and 10 ETH must be converted to Wave. So that will be 10 times 10 raised to power 18. Alright, so that's good. I think that's about it. So let's include command to run this in our make file. So in my make file, I'm going to put this command there, start app. So whenever I run make start app, it's going to run this command. It's going to come into our script, call this interaction with bots script, and call this contract. All right, so let's our local blockchain is still running, and we've deployed already, so we should be fine. So let's try and run make starts app, and let's see if everything goes well. We should fail, or it will fail as we intend, as expected. But let's see. Okay. All right, let me restart our network. Make Anvil, and let's see. This is make Anvil. All right, we started now. Now let's deploy the contract to it. It's deployed. Then let's run our startup script, and let's see. Okay, it has failed, but not as I wanted it to fail. It's reverting with unauthorized. The challenge here is this. The start arbitrage requires whitelisted address, but the address I'm using is the owner address. I have not whitelisted the address before I'm calling this. So I need to come here and whitelist the address. So let me just, so of course the address I'm using to deploy is the owner address, but it's not whitelisted yet. So I'm going to come here and whitelist the address. I'm going to change this to public so that I'm able to whitelist the address. Yeah, so copy this, then come here. Once it comes in, so we whitelist the owner immediately. Another way to fix this error would be to just come here and in the constructor, instead of me calling the function, I can just directly call the mapping. So I'm just going to set the owner or whoever deployed this contract. I'm just going to whitelist it here. So I can change this back, delete this, and change this back to external. External means that the function can only be called outside the contract. All right. So let's again restart our blockchain. I'm going to make Anvil. It's going well. I'm going to deploy the contract again. Let me ensure that it's saved. Deploy. It should deploy now. It's going. Yeah, deployed successfully. Then we can now start our arbitrage, and hopefully this time it feels the way we intend it to feel. All right, variable borrow rates. It's well, okay. This is interesting. So over here we can see the functions that we called in our script. We started by calling this is flash loan enabled. Yes, this is what we called first. It's flash loan enabled and it returns true. That means that our interaction is working well. Let me scroll down. Yeah, this is console log and this is where it returns true. All right, so our arbitrage, we start the arbitrage, we call flash loan simple on Aave. All right, everything seems to work well until, don't forget that we borrowed 10 if 10 wet wrapped Ethereum, but now the contract at the end, Aave wants to deduct more than that because the premium has to be added. 0.05 fee has been added, but we don't have up to that in our contract. That's why we are getting this error, and we are going to resolve that by funding our contract with wrapped Ethereum. We are on the local network, so we can always play around with this. Anvil gives us about 10,000 ETH to play around with on the local blockchain. Of course, this is not a real money. You can't use this on the mainnet. So we are going to convert some of the ETH to wrapped Ethereum, fund our contracts, and see if this everything will pass. To come to fund the contract with Weth, we need to import Weth interface. So I'm going to create a folder here called interfaces, and that's where we are going to put our Weth interface. So here, if you go on Basecamp, you would see this interface for Weth, and you can copy it there. In Solidity, if you want to interact with the contract, you need the contract interface, the contract API, and the contract address. So this is the API that we need. Now, with that, and we are going to call this deposit function to help us wrap our if to Weth, and we'll use it in the contract. We need to import the Weth interface into our interaction script. So over here, this is our Weth interface. Then I'm going to write some functions to interact with the Weth contract now. Alright, so this is the script to fund our contract with Weth. I don't want this video to be unnecessarily long, so this is the script I've already prepared. So what it does is it sends 100 if the amount is 100 if it sends it to Weth contract by calling deposit function on it. Now, when you do that, the Weth contract automatically mints equivalent amount of Weth and send it back to your contract, or send it back to the sender in this case. So yeah, and once we have that in our wallet, you have Weth in our wallet, then we can now fund the contract by transferring 100 Weth to the contract here. So we call this function fund Aave bot. All right, so since we have a new script now, we need to add this command to run this script to our make file. Now let's write the command to fund to get worth. So this is the command. Now we can now try and test fund our contracts and do this test. Hopefully everything goes well. I'd love to. I'm going to restart this. You just need to do Control C on Mac to stop the local blockchain. Now it has started. Now let me run make Anvil. Oh, deploy rather. I'm supposed to deploy the contract. The contract is deployed, still deploying. All right, before we run the code again, I'm going to console log the final balance of the contract after the arbitrage. So that will help us to know whether the arbitrage was run successfully and the balance, worth balance after we run the arbitrage. All right, so let's restart. We're going to start our blockchain again. That's make Anvil. While it's starting up, I'm going to now deploy the contract again now. Hopefully everything goes well now. The contract is on now. The local blockchain is on. It's currently, the contracts are being compiled now. All right, that's good. Having this one is, these are variables we plan to use later. All right, so it's been deployed successfully. So let's fund the contracts by running make get worth. This is the script we are running. It's wrapped our 100 ETH to 100 worth and fund our contract with it. Sends that to our contract. So our contracts have 100 worth. That's the initial balance of our contract. It's here above before. So we are now going to start the contracts, the arbitrage. So I'm going to run the arbitrage now. Hopefully everything goes well. Now we have 100 worth as the balance of the contract. It will borrow 10 worth and be able to pay 10 worth plus 0.05% fee. All right, that's good. So these were the things we console logged here. Is flash loan enabled true? This is it. Worth balance of our bot, the arbitrage bot. This is what is left. So 0.05% fee, which is the premium, has been deducted. So everything has gone well. Please feel free to pause the video and copy the code. So far, our bot is able to take flash loan from Aave V3. We've been able to implement that. It could take either USDC or worth. We tested with worth. Then is able to repay the flash loan with 0.05% fee. And the second part of this video would focus mainly on exploiting arbitrage opportunities. With what we have so far, if you have other opportunities, other strategies you want to implement with flash loan, you can use the contracts for it. But the second part, it will focus mainly on arbitrage opportunities. We are going to implement swapping on Uniswap V3, Aerodrome V2, Pancakeswap V3, Sushiswap V3, and Alien Base. Please don't forget to like the video, subscribe to my channel so that when the second part comes out, you are able to be notified. Thank you so much, and I'll see you guys on the next one.